Hey there guys, this is a video for the 5.3 notes, graphing systems of linear inequalities. First things first, you've seen these type of graphing. Now, system tells us that we have more than one line on the same graph, or more than one equation in the same problem. So you already have had experience with graphing inequalities. Now we're going to be graphing multiple inequalities. First, as a reminder, we have some symbols: less than, greater than, less than or equal to, greater than or equal to. Less than symbols will give us a dashed line, as well as greater than symbols. If it is strictly less than or strictly greater than, you will have only dashed. Versus if they have the bar underneath, such as less than or equal to or greater than or equal to, you will have solid lines. So it stands to reason, if it is not equal to, then we will want to show that not every point on that line is a solution. So we will have dashed lines, which remember look like this, regular lines with spaces in between them. So that is for both just less than and then just greater than. And then solid lines will be if you have the bar underneath, less than or equal to or greater than or equal to. Now, shading also differs between your symbols. So, for example, if you are strictly less than, well, it makes sense. If you're less, then you're going to shade below. So, assuming that we have our dashed line, shading below means we're going to shade all this region here, below my line. Similarly, if you have less than or equal to, you are still going to shade below, except you'll just shade below a solid line. If you have greater than or equal to, well, it makes sense that greater than is going to lead to shading above. Whether you're shading above a dashed line or solid line. So this is your chart. You can use it as reference. The more you do these, the more you'll start to find the patterns, such as, like I mentioned earlier, if it is greater than or less than or equal to, or greater than or equal to, it's always going to be a solid line. If it's just greater than, whether greater than or equal to, shade above. So you'll find the patterns as it goes along. And the general steps for graphing systems of inequalities is first you want to start with one equation. So as always, you'll graph one equation at a time. And as you're graphing the equations, you're going to start with your y-intercept. And then you're going to use slope, so your m, or the number touching x, to plot the other points on your line. So remember, always start with the y-intercept, and then you use slope to get the other lines. Now, when you connect your points, you have to be careful. Usually, when you're graphing, you just collect up with a solid line. However, you will connect your points using a solid or dashed line for system of inequalities. So always make sure to check. I know it's very habitual to just want to connect them with a solid line, but always check in case it's a dashed line. It's always good to use pencils in the case. A lot of students will make the mistake of always doing solid lines and then realizing afterwards it had to be a dashed line. So try to use pencils. And then once you've drawn your line, either solid or dashed, you're going to shade above or below, depending on whether you are less than, which is below, or greater than, which is above. Now, the solution, because remember, when we're doing this system of equations in the previous lesson, you're looking for the solution. Well, the solution for systems of inequalities are where the shaded regions overlap. That is to say, where we do example 1, and we're going to look for where our two shaded regions overlap. So we have two equations. Y is less than 5 over 2x plus 2, and y greater than or equal to 1/2 x minus 2. Now your first step is always start with the y-intercept. I'm going to start with my first equation. I'm going to call this line 1. My y-intercept is the number without x. or being added or subtracted to my slope. In this case, it's 2. So since it's my y-intercept, I'm going to look on the y-axis. I'm going to look for 2. That is my first point. This number is my slope. So this will tell me how much I go up and how much I go over. So since it's a positive 5, I'm going to go up 5. Since it's a positive 2, I'm going to go right 2. Up 5, 1, 2, 3. Notice I can't go up 5. I run out of space. So if you don't have enough space to go up, you can still do the same thing. Just go the completely opposite direction. So instead of going up 5, I'm going to go down 5. Instead of going right 2, I'm going to go left 2. So down 1, 2, 3, 4, 5. And then left 1, 2. So notice you end up with a point here. You always want to make sure that your 2 points, when they're connected, they will create a positive slope if you have a positive slope in your equation. In this case, yes. If I connect these 2 points, it will create a positive slope. Now before you connect these points, you want to look at your line. Notice this one is strictly less than. So if I look at strictly less than, here it is. It's a dashed line, and I'm going to shade below. So I will take any straight edge I have, whether it's your ID or a ruler, and you will connect them using a dashed line. So leaving in between spaces. Also, don't forget to draw your arrowheads when you're drawing these to show that they go on infinitely, as well as going from one end of the graph to the other end of the graph, not just stopping at your 2 points. It should go all the way. So that's your first line right here. Now we're going to have our second line, y is greater than or equal to 1/2 x minus 2. So in this case, we're going to say, okay, well, minus 2 is my y-intercept. So on my y-axis, I'm going to look for negative 2 right here. Plot my first point. My slope is 1/2. It's positive 1/2, so up 1 over 2. So up 1 over 1, 2. And keep going until you run out of space. Up 1 over 1, 2. Up 1 over, can't do any more. So go in the opposite direction, down 1, left 2. So I end up with another point here. Down 1, left 1, 2. This one is greater than or equal to, so greater than or equal to is going to be a solid line where I shade above. So it's going to be a solid line with no spaces. And remember, going end to end. Don't just stop at the point. Now I haven't done my shading, so I'll do my shading now. I prefer to keep shading at the end. You can do it after each line. It doesn't really matter. Now for the first one, it was less than. So here, this one was less than. I'm going to shade below my line. All spaces below my line. So that's the yellow region. For the next one, it is greater than or equal to. So that means I'm going to be shading above. Well, above my line 2 is here. So everywhere above my line. That includes here, here, and here. Now, the yellow is a solution to my first line. The blue is a solution area for my second line. However, notice this kind of greenish area, this greenish meets both criteria as a solution to my system. So remember, the solution is where the shaded regions overlap. In this case, I have a combination of yellow and blue. So this is my solution. Now, it's not the yellow region that is only the solution to the first equation. It's not the blue region that's only a solution to the second equation. It's this green region right here. It's a solution to both. We're going to go a little bit faster for the next ones. So for the next equation, you have y less than negative 2x minus 3 and y less than 1/2 x plus 2. Start similarly to before. Start with your y-intercept. My y-intercept is negative 3. So I'll put a line here. My slope is negative 2. However, I always like to make whole numbers into fractions, so I know my right over run. So down 2, right 1. Down 1, 2, right 1. So I went down to right 1. I can also go up 2, left 1. Up 1, 2, left 1. And notice, as I'm creating my points, this is indeed a negative slope. because it's decreasing. So once again, up 2, left 1, up 2, left 1, up 2, left 1, until I have no more space. Since it's strictly less than, you can look at your chart. The strictly less than means it's going to be a dashed line. So I'm going to leave spaces and go from edge to edge. My next equation has a y-intercept of positive 2, so I'm going to look for positive 2 right here. And it has a slope of 1/2, so up 1 over 2. Up 1 over 2. Up 1 over 2. Go in the opposite direction. Down 1, left 2. Down 1, left 2. Down 1, can't go anymore. Strictly less than, so once again it's just dashed. Now I can start my shading. My first line is less than, which means I'm going to shade below. That was my pink line. So below my pink line is all this region here. Your shading doesn't have to be perfect, just make sure you can tell what region is below. Similarly for the second one, it's also less than, which means underneath my black line, I'm going to shade below. Now hopefully at this point you can figure out on your own which is the solution area. Remember, the yellow region is just the solution to the first line. The blue region is just the solution to the second line. The greenish region is the solution to both lines. So in this case, my solution is down here, this little triangular section. Finally, we have these equations. Now this was from 5.1, doing your Hoy bucks. So I'm gonna write Hoy bucks. Now this is just y and the equation. Now you may be able to just say, hey, there's no slope, so my slope is 0, my y-intercept is still 3. That works out. But using Hoy bucks, this is y equals, which means you're going to have a horizontal line. So at 3 on the y-axis, because it's y equals, you're going to have a horizontal line of 3. Since it's less than or equal to, that means you are going to have a solid line. Whereas for this one, it's just an x. So this is going to be my x equals, which means it's going to be a vertical line. Where on my x-axis, I look for -3. And then I create a vertical line. Now be careful, this one is strictly greater than, which means you're going to have a dashed line. So this equation is y less than or equal to 3. Once again, we knew it was horizontal because Hoy bucks, it was an equation with y equals a number. Therefore, it's a horizontal line. That's what the h stands for. And then you took the 3 and put it on the y-axis because it's a y. For the second one, it's x equals a number. So it is a vertical line. That's what the v stands for in bucks. And since it's x, you put the -3 on the x-axis. Now we can shade. So for the first one, we are the black line, y less than or equal to 3. So we're going to shade below, since it's less than, everywhere below this line, which is most of your graph, but that's okay. Then we have x greater than or equal to -3. Now this one's a little bit hard because you don't really have an above and below section. So you have to think about what this inequality is telling you. My solutions are all x values greater than -3. Well, where do you have x values greater than -3? Well, 1 is greater than -3, 4 is greater than -3, -2 is greater than -3. All these x values are greater than -3. And that's really what we're doing for shading. This one tells us all y values less than or equal to 3. Well, y values less than or equal to 3 include -2, -5, 1, 2. That's what we shaded below. But in this case, since it's greater than -3, my x values greater than -3 are here. So we're going to shade to the right, which makes sense. Greater than is going to be right, less than is going to be left if it's a vertical line. And once again, hopefully at this point you can tell what the shaded region is. It's where we have this greenish area here. So your solution area is kind of the square down here. And then your graph, that's how you graph systems of inequalities. Remember, you're not done until you find the solution region, which is where you have two shading. It's most helpful to use highlighters for these since it gets a little bit tricky if you're using pencils to tell where the shading is, or if you're using pens. But try to use two different colors. If you have any questions, feel free to sign up for tutoring or ask your teacher.